I am happy to have with us today from NEF, John Bridgen, and John is going to take a moment and introduce today's presenter.
Yeah, good morning, everyone. Thank you for joining us. As you know, what we're trying to accomplish in these sessions is make good use of your time and effectively introduce you to leading technologies that can make a difference in your manufacturing processes today. Cognex has been well thought of as a leader in both hardware and software technologies since the early 2000s and before. We're pleased today to have Nate with Cognex. Nate has spent the last 8 years of his career with Cognex and is deeply involved in getting educated on the new technology Cognex releases and works closely with NEF to allow us to qualify solutions that you may have, challenges to determine what's a good fit. We're particularly excited today to leverage Nate's experience to hopefully bring some insights to you. Nate has 18 years of manufacturing experience and generally serves the Eastern Ohio and Western PA markets. And we appreciate everyone's time. And Nate's going to talk about two technologies here as shown here with the artificial intelligence tools and the 3D tools that are very impactful and exciting. So with that, Nate, we look forward to learning more. Thank you.
Thanks, John. Thanks, Molly. Appreciate everybody's time. As I said, my name is Nathan Kufel. Anyways, just kind of wanted to, we'll get jumping right into it. Today's agenda, for the most part, we're pretty much going to cover all of the deep learning with the D900 series. And then probably like the last 5 to 10 minutes, just wanted to introduce to you a quick little PowerPoint on our new 3D L4000 3D smart camera. It's something that we just came out with about maybe about a month and a half, 2 months ago. So it's just new technology. All right, so before we also get started, jumping into it, also wanted to just let you guys know that I do cover Western Pennsylvania. However, my area is mainly in the Cleveland, Akron market. So I do cover Erie and Meadville, generally in that area. If you're a customer that's outside of that, if you're more into Pittsburgh, Newcastle, St. Mary's, Altoona area, then I did put my my partner's number down there as well, Chris Pecknick. You can get his phone number and his contact information as well. All right, so jumping into deep learning, what is it? It's really a nice mixture between human thinking and the reliability of 2D machine vision. You get it's the best technology that kind of merges those two together. How is it different than standard vision that you probably are familiar with? Well, first off, the algorithms themselves are not rules-based. It is a little bit of a black box scenario of what goes in, but you're basically teaching it through an image database rather than sending, specific patterns have to look like patterns, edges and blob tools all have to have certain thresholds. It is complementary. We do have 2D vision and 3D vision in the same software so that they can use it. And I'll kind of get into when you would use deep learning versus standard vision as well. What sets our products apart? I'm sure if you did some quick research on like convolutional neural networks and deep learning, there is free stuff out there with, Google, Facebook, all of that sort of stuff. But the big deal with them is you need thousands upon thousands of images. We don't. We're generally in the 100 or less category. You don't need a server farm. You just basically need a laptop with a GPU. Think of like a gaming laptop. Most controls engineers already have that anyways, so it's already there. It works with all sorts of images. So whether you want to use a bitmap JPEG, you can use Cognex, you can use Keyence images as well, any of our competitors. I've even done it on applications with a microscope that actually acquires pictures too. And then obviously with deep learning, it's just like human thinking as well. It can handle the optics and effects if you might have a little bit of a blurry image, or maybe your lighting's not perfect as well. The results from that, quicker learning for your training. Like I mentioned, we're in the 100 area rather than the 100,000. So obviously development time is significantly less. Our training for that, since you're not training on that many images, doesn't take that long. Really depends on what GPU processor you have, but 4 minutes to 40. And then you don't need to be a vision expert. All of our software, it's primarily pretty quickly to pick up, especially if you've already had some experience with it. So let's talk about deep learning, and here's kind of an idea of how it works. Okay, so if you have an application where, say, okay, here's my standard vision system, and I want to be able to find a cat. Okay, I take the picture, and there's my pattern that equals a cat. However, that next picture that comes out, or the next product, that's a cat, but it doesn't meet that that pattern. So that kind of creates a little bit of a conundrum. So maybe you have to retrain it, or add some logic, or maybe you have to add additional patterns to it. But here's the issue that ends up coming up: is we all understand as humans that these are all cats. These are all cats, but that vision system that you trained with traditional algorithms does not get that. And so what we do with deep learning is now we acquire all these images of cats, okay? And what we do is we pump it through our system, the convolutional neural network that we have called Insight-ViDi, and out on the other end, all those different images comes out the result as a cat. So where would you use deep learning versus traditional vision? First and foremost, in applications where you already have a vision system that's not meeting your expectations. That's going to be your number one lowest hanging fruit, because you already have that image database either created or the potential to start acquiring those images. Other applications would be where you might walk away in the past because it was just too confusing to do. So typical applications of where you may want to jump in traditional versus deep learning. So measurement, gauging, high accuracy measurements. You're using a telecentric lens, a collimated backlight, and a standard vision system. At that point, you're just getting a silhouette. Use edge tools and you calibrate the camera, and you've got a high accuracy measurement system. You don't need deep learning for that. If your parts are precisely aligned, we can use standard pattern recognition algorithms like PatMax. Works perfectly for that sort of stuff. And then also barcode reading, 2D, 1D, all the above, QR codes, all that sort of stuff. We can use our DataMan products as well. But when you want to start getting into inspections, okay, maybe with some randomness or cosmetic defect inspections where you got a lot of subjectivity to it, that can be a very difficult one. Natural products, think of wood. That's a perfect application where the naturalness of the wood, looking for cracks. How do you know if it's a crack versus a knot or just a small stain? Welding inspections. If you look at it on a macro level, you're applying the same amount of paste. You're heating it to a certain level. It's all pretty much the exact same process. But if you looked at that solder once it's been melted on a micro level, none of it ever looks the same. All right, and that's a real difficult application to do. Confusing part alignment, robotic pick and place applications. This is a great one if maybe you only have one camera positioned above and it's not moving directly perpendicular or directly over the part, so you get a lot of distortion. This is a great one. We have a tool for that. And then OCR applications, and I'm going to get a little bit more into that as well. The other thing it also does is it really simplifies your vision programming. As you can imagine, traditional rules-based, just like with all those cats that we had, this is a pretty much a rat's nest over here of all your inputs and outputs. It's a lot to really to program, and it's a lot to keep track of. Whereas with deep learning, you basically give it all your good, you give it all your bad, what comes out on the other end, and then you have a slider bar scale that you can move for acceptance rates. Makes life easy. So we'll jump into it. This is the D900 series smart camera. We have 2.3 megapixel and 5 megapixel so far. They are monochrome, and color has been fully released as well. The cameras have a global shutter, so that just means that we can acquire images on the fly. They don't have to be stopped or indexed. The camera itself is quite modular. So if you look at the body where it's the yellow and black, that's where you're going to pick your 2 or 5 megapixel. And then the lighting options that we have, this is called our torch. So we have a built-in light that you want. So it can go red, white, blue, or IR with correlating filters, diffused covers, polarized covers. You can use the C-mount lens with it, or you could use an autofocus lens. Or say you didn't want this at all, you could just not use this, use a standard C-mount lens, and then use your own external lighting as well. So it's completely open to your application. It's IP67, so there's a harsh environment rated, and then there's a ton of memory ability on board, 7 gigs on, and then you've got 8 with an additional card for 15 total. So with standard vision, how it basically works is you take your image, or I'm sorry, you take your camera, you take your golden image of a part, and then you set your parameters from that. And then you're ready to go. If your application is accepting of that, then that's perfect, and that's pretty much what everybody's used to. With ViDi, with our PC Vision platform here, it's a little bit different. So what we need there's 2 must-haves. All right. First off, you must have a development dongle. Okay, this gives you access to the deep learning portion of the software in Insight Vision Suite. You can download the software and open it up, but the second you need to get access to the deep learning, you need to have this guy plugged into your laptop. You also need a laptop with a GPU. That's going to do all of that, all the heavy lifting, basically, of all those images that you've acquired. So how it works is you basically, you take your pictures, you have your GPU, and then you have your development dongle. You train and develop in the software, and then you export a runtime job file onto the deployment camera. Deployment camera does not expire. It's basically just whatever version of Insight ViDi Suite that you programmed it on, that's what it's on. You do not need to have the laptop or an industrial PC out on the factory floor. This has all of the parameters and settings from this development, but just not on the images are not on the camera. So it's a standalone smart camera, pretty much like our bread and butter architecture that we do with Insight. So jumping into the defects. So the first one that's the most popular is our defect detection. Any shape, any size, anywhere, with the caveat that as long as you can see it, so can ViDi. That's a big difference between standard traditional vision, where if you have a defect, you generally have to have the tool placed over the region of interest in order to find it. With ViDi, you do not. We have 2 different modes. We have unsupervised, and then we have supervised. All right. Unsupervised, I always reference it as basically the easy button here. So what you basically do is you acquire 20 to 50 images of good product, and then that's what you train it on. So your development time. So if you're in the industry, or if you're in the customer says, hey, I only have, like maybe 2 defects once every 6 months, this is going to take me forever, then we don't need to use supervised mode. We can go and jump into unsupervised mode, where you literally train it on good products. If you do have some bad images to throw into that software, that helps out, because it helps for statistical purposes and judging what's good and bad, but you're not sending it into the training. Now, on the other side is supervised mode. So supervised mode, definitely is a little bit more on the developmental side, because what you're actually doing is this is where you're going to tell the software, in the software with basically a paintbrush, you go through and you actually paint what the defect is. So it can distinguish the difference between a crack, a divot, a burr, missing material, because you're going to actually go through and tell it, this is a defect, this is not a defect. Takes a little bit longer to program, but it's significantly more robust. Think of supervised mode as almost like training a temporary operator. When they first jump into work, they don't know the difference. You probably have a scope of work for them, or you probably have a standard operating procedure, what to look for, what to pass, what to fail. And just like them, it probably takes them a little bit of time in order to figure out the whole process. Same with supervised mode. So you want to have it segmented to your defects in a folder for maybe cracks, maybe divots, maybe missing material. And then over time, you're acquiring these images, you're training the software, and then it becomes a fully functional, robust system looking for those specific defects. So we'll jump a little bit into unsupervised mode. So what's kind of nice about this is what we're doing is we're taking pictures of something that looks very similar. And then when we get a scratch here, it's able to find it. It's looking for anything that's pretty much out of the ordinary. So even though your backgrounds slightly change, you can still tell, hey, look at that, what we're finding. Same over here. We have, generally speaking, pretty much the same background. And so we're able to find these any shape, any size, anywhere defects. This one, I believe, is wallpaper. And you can see over here where it finds the smudge right there. It's able to pick that up. Very confusing background too, and it's able to find that. Pad printing is another great inspection for VIDI Red unsupervised. Simply being, majority of the time, you're taking good images of your pad print or that print defect that you're trying to find. Much easier to find because either it's going to have missing, so maybe you'll have black where it's supposed to be white, or white where it's supposed to be black, where you get this smudge somewhere across. Makes life pretty easy for somebody to be able to pick up, or a camera to be able to pick up. This is another one that I like to show because this brush metal surface, as you can see, the amount of grayscale variation is very difficult. Trying to put a blob or a pixel count or even an edge tool, you can see how it just jumps back and forth between all of these. It'd be very difficult to put something down. But then when we go to find an anomaly here, it's able to see it. What I like about this one is you could say in this previous application, well, we'll just look for a blob of black pixels. Okay, you may find it on that one, but on this one it'd be very difficult because not only do you have the black, but then you also have the white there as well. Small scratches makes life easy. Jumping into supervised mode. So with this one, it's basically just showing, hey, we're able to identify whether in this application, this one is a defect or not. It's just able to say, hey, we can find it and outline it and say, hey, this is what you're looking for. Maybe it's not what you're looking for. Jumping in over here, maybe that's the defect because we're able to see, it looks like probably like little pieces of metal that were supposed to be soldered over as well. Jumping into like a steel rail inspection where you've got a wide variety of how the presentation of the part looks. Like I mentioned, you've got missing material. Up over here, you have a burr probably, so with extra material and scratches up along the center of it that maybe aren't acceptable to a customer's requirements. So it's able to find that. And in these applications, this is where you're basically saying you would go through and you would say, okay, I need to paint this, I need to paint it here, and I need to identify and maybe make paints right there. so that it sees that. Cast iron inspections, turbine blades, kind of shows you on a more zoomed in look right here, where it doesn't look the same. Very, very difficult to be able to pick up with traditional vision for that. OCR. Honestly, I'm very, very excited for this one. OCR is a big part of my business because it's pretty much in every industry: automotive, medical, aerospace, consumer packaging, customer electronics. It's all over the place. And a lot of the times it can be very difficult to read. So very similar. What you're doing is you're going to collect your images. You're going to identify the alphanumeric texts. You're going to train it, and you basically validate it. So where I say now, when customers come to me and say, when do I need to use deep learning? When do I need to use traditional vision? This is what I explain to them. And I say, Mr. Customer, Mrs. Customer, think pharmaceutical, okay? Where you have a nice, well-printed text. Doesn't have to be black versus white contrast. You just want to have a nice contrast. Also, font, same shape and size. So that means your product is not moving in and out, or you're not moving the camera back and forth, so that depth of field doesn't change. You're always looking at the exact same over and over. And then the biggest one is you have intracharacter separation. Okay, what I mean by that is if you look over here in some of these where, like over here, the 4 and the 0 are actually touching. OCR is a very, very traditional rules-based algorithm. You're telling me this is what I'm supposed to look for. Okay, that's great. But if it starts to change, you need to either add more to the font library or you need to retrain. Either or, it starts to have a rolling down the hill effect by either introducing more to the library, which means it's going to run slower, or you're going to get intracharacter confusion if you start to lower the acceptable threshold. So with deep learning, once again, think of it like humans. We can clearly read where it says APR03, but it's all curved. That makes life very difficult, especially on a rules-based algorithm. Deformed OCR, like on a tire, very, very difficult because it's rubber. It's black molded. Those are only 40 thousandths tall characters. A lot can go wrong with that. So we can read that. And then Inkjet. This tends to be the most popular one, and it tends to be the bane of my existence when it comes to trying to using standard cameras, because you get a lot of variation, whether it's the actual print head is moving back and forth based on how the operator set it up, or it starts to get gummed up over time, or you get extra spray and maybe like a tiny little blob is touching a character. Those are very, very difficult for standard vision. But with deep learning, it makes life a whole lot easier. These are just some types of applications and examples that we're clearly able to read. Stamped metal characters. Literally just did one in Cleveland here, where the stamped metal was a hydraulic press, and when it was starting to run low on fluid, the pressure would change. Even though it was the same stroke and it was the same metal, the characters would look different based on how much pressure was actually applied. So you can imagine if it's like clean and crisp versus kind of like mushed in there, it's going to look different. And when you trained it, what did you train it on originally? Did you train it on the mushed, or did you train it on the clean press? Molded characters and plastic parts. See this one all the time. Customers want to know what the mold identification number is. Characters that are in engraved metal. There's another one. Characters you can see right here, placed close to the barcode. Maybe it's the date lock code or anything like that, where it's actually touching the barcode. That right there, that would make the 9 very difficult because there's hardly any separation. Over here, any type of curved products. On this one, this is actually on some pouches on a medical IV bag. So you get very, very confusing backgrounds. You could imagine with liquid back there, with it being clear, it's never going to look the same. Think of food. That's another one. If there's any customers on here that are in the food industry, I see this one all the time for food containers, especially around the 4th of July, which is coming up. You got the same container, but maybe in the background, you've got baked beans. Maybe you have coleslaw. Maybe you have pasta. Maybe you have potato salad. Can you imagine all the differences of how those look on those clear containers with the background? Very, very difficult to do. Here's a classic one. I'm sure most people never really think about it, but on the back of a tuna can, that's about as tough as it gets. That's terrible, terrible print. And then it's also, it's now 3D because it's moving up and down on these, on the edges there, or the ledges. It's not just flat. Here's another one, VIDI check for assembly verification. If you're into medical kitting, if you are into electronics, or maybe something where maybe you need to make sure wires are present or nuts and bolts are there before you put the top of a cabinet on, maybe an electrical panel for any sorts. Perfect application for assembly verification. Blue tool. This one's a fun one. This is one where I was talking about robotic pick and place. In this application, you can see the camera is pretty much in one single position, probably mounted over the center. Very difficult for this one. You couldn't use a blob tool or a fine circle tool because obviously you've got all of the variation over here. And then also with the distortion, if we're looking directly over a circle, it probably does look like a circle. But as you get further out, you get distortion in the lens and just makes life very difficult to be able to pick up. So this one's a medical vial pick and place, but you can use it for a lot of different applications. Here's another one, cutting tools. I always like to tell customers, once again, when I talked about deep learning, if you any shape, any size, anywhere, with the caveat that as long as you can see it, so can VIDI. Obviously, it's not going to be able to pick those two up because they're basically missing. Green classify tool. This is a fantastic one. So this can be used all over the place. For one, part kitting, but also product classification. And then also you can tag this along with the red tool for defect classification as well. So do you want to know, is it a scratch? Is it a burr? Is it a crack? Is it missing material? Once VIDI red finds the defect, then green can then classify it. Fantastic way to be able to actually grab the bull by the horns and find out in your process where is the defect starting based on what type of defect it is. VIDI green, very simple too. Collect all your images, label them, train them, and then you validate them. Here's one I think is just perfect for deep learning. Natural product. And in this case, we're looking at chicken parts. This would be one of those where it would be impossible, most likely, to jump in with standard vision. This would be one of those, thank you very much, I appreciate it, but probably too hard to be able to do. As you can see, we're able to tell the difference between all these different cuts of meat. Very difficult to be able to do with natural products. Here's another one, product classification, especially when we're looking at the difference. That's pretty tough. I'm sure we could potentially get away with standard vision based on what we look at, but what if the application, doesn't allow for the inspection of, we're looking at whatever it looks to be provincial and whatever the other one is underneath there. That could be pretty tough to be able to do. The caps are the same. The labels are almost the same. There's a slight different color in green, but not much of a different shade. By simply training it to what to look for, we can classify and discover that difference. Same one here. These are both very, very close. We're able to tell the difference. Here's another, looks like medical. Looks very, very similar. And that's kind of it for deep learning. Molly, do we want to jump into 3D L4000, or do we want to maybe pause now for Q&A on deep learning?
Well, we don't have any questions in the Q&A box just yet. So in the sake of time, why don't we go ahead and go forward, but I'll invite anyone with any questions to go ahead and put those in the Q&A box, and we'll make sure that we get to those. But why don't we just move forward just to keep things moving, since we're this is such a short session.
Fair enough. All right, so I'd like to also introduce some new technology here called the Insight 3D L4000. It is a smart camera that is able to use 2D vision and 3D vision as well in a single camera. Couple of nice things about it as well. It's got an 8-core processor. So it does not require a controller. All of the guts, the imager and the processor are built into this. The only thing you basically need are your power and communication cables and a 24-volt power supply to power this guy up. We're using true.
You're still seeing your deep learning screen.
Ah, okay. All right, you guys see it now?
You're good.
Okay. All right, so jumping over here so that you can kind of see it, 8-core processor, smart camera, all the internals are built into it, no controller needed. We are actually working on a point cloud. So what's nice is you are actually working off of true 3D data. You are not taking that 3D data, converting it down to 2D, and then running your inspections. You're getting all of your data and working in on the 3D. We have a new type of speckle-free blue laser. It's a patented laser image. Very nice, crisp, clean images that you can get from it. A little bit about the hardware of the camera. It's IP67. It is a 2K resolution. So the camera is it is a line scan. It's not an area scan. So what that means is rather than the pixels all being acquired at once, like an area scan does, a line scan has 2,000 in the X direction, but only 1 in the Y. So you either move the product underneath it, or you move the camera over the product, like on a linear actuator. You can do it time-based or encoder-based. And what that does is it's basically giving you slices of an image called a range image. And then once you're done acquiring, it assembles that all together. All right. Up to a 4 kilohertz scan rate as well. So it's pretty quick with what you're using. What I like about this as well, if you are a Cognex user and you've used any of our Insight products in the past, it's now called Insight Vision Suite for our 3D L4000 and our deep learning. It is free software for this one as well, but it programs off of spreadsheets. So if you've already programmed some of our cameras in the past, the learning curve is significantly less. It also acquires, because it is a line scan camera, it acquires 2D images as well. So not only can you acquire and work off of 3D, but then you can also work off of 2D and use simple 2D applications. So maybe if you have a prime instance is an application where you are maybe scanning a tag. Maybe it's a laser engraved tag that has a barcode and maybe a serial number. So you need to be able to read the barcode, but then also read the engraved OCR and maybe also get the depth. Perfect application for something like this. You can see that we have all of these new features here for extracting 3D information from it, whether it's an edge, a sphere, extract 3D blob. We have all of those. Here's kind of the image that we have. Here's one with the standard grayscale, and then here's one where you can actually adjust the color for your likeness. True, once again, 3D vision tools. Blob 3D. Kind of show that a little bit. Quickly shows a little bit of the programming. What we're going to do is do a quick top-down approach from the view, and then we have this quick draw box. Sets it up. And you can see in the 3D landscape there, you don't really need to look underneath the block. We'll just look just on the top and potentially below. And now this is saying, what plane do we want to use? And we're going to use the estimated plane that we already had. How many blobs do we want to find? Well, we've got 6, so we're going to find 6. But you can see there we're not picking up the other one. So what we have there is called a negative blob, so something that's below the surface rather than above the surface. And Blob 3D extracts all of those and then gives you volume, height, and number. This one I think is fantastic. Edge 3D. I've used this one a number of times already as well. It's going to pull this one up. We're going to reference off of the quick drop box once again to draw our region of interest. And then this time we're going to look over this triangle. You can see where it's pulling from. And then how many edges do we want to find? And then what types of edges do we want to find as well? So that's able to find all of that. So you can get all different. We've got circles, spheres. If anybody out here is looking at tube applications, maybe welding tubes together, forming tubes, extract sphere is a brand new tool that we have. Makes life pretty easy. Mentioned before, complementary 2D and 3D vision tools, all inside one programming environment. Here are the models that we have: the 4050, the 4100, and the 4300. Just a quick image showing you again. More tools, specifications as well for what we're looking with. So what we also like to show is the top and bottom, since it's a it has the measuring range. Back here you have your near field of view and your far. So the closer you are to your product, you're going to have a smaller field of view to look at. The more you back it up from your product, you're going to have a larger area to see. So that's why we have a difference in our resolutions that we have, which you can see with the repeatability and the linearity as well. And there's just the breakout for you as well. All right. wanted to jump into any Q&A?
Nate, someone had texted me a question about costs, and of course there's variations in applications, but one thing I'll share, and maybe you can elaborate on, Nate, is obviously there's a hardware cost, but the biggest benefit specifically for the VIDI products that also connects to 3D, but for VIDI is the reduction of cost of implementation. Meaning once you have those images, it becomes truly a set it and forget it. I've seen many people with rules-based vision, and every week, every job, every condition, they're out there retraining. Those costs virtually go away. And additionally, you're able to do those more challenging applications as well. So it's kind of counterintuitive that you can do the more challenging things with actually less an investment in labor and programming. So you might be able to elaborate on that more, Nate, but I think when you're investigating the costs, you really have to think carefully about not only the hardware, but the implementation time, because both of these tools are actually very reasonably cost effective. But in terms of deploying them into your production and getting the results you expect repeatably over time without touching them again, that is where the ROI actually really gets generated quickly. So Nate, if you can elaborate on that, that's just some points I wanted to answer to that question.
Yeah, so I really try to inform customers of, try to set the expectations up front. You're looking at hardware costs between 10 and 20K. That's gonna really depend on what resolution camera, lensing, lighting. You need a development dongle, all that sort of stuff. So there's going to be that, but I really liken it to replacing like a temporary worker. It's darn near the same process where you are acquiring images from an image database. You are training said application, okay? And then after that, you are going to have a little bit of a development time, because let's just say you take all of your images on Monday, okay? From 8 to 4, you acquired 250 images, and that's what you trained. Well, it's not necessarily true that you're going to find the same defects on Tuesday, Wednesday, Thursday, or Friday. You may have different suppliers that provide you the same metal, but they don't all come from the same place. Or even the plastic pellets that you have, or anything. You're not always going to have the same defects just because you took all those pictures from that day. So you do have an optimization period, just like you're training this worker, where you can save said failed images, or maybe you have some, I call them, they're called interpolaries, but maybe you have like fence riders, where we're not really sure if they're good or we're not really sure if they're bad. So you save those images, and maybe at the end of the day, at the end of the week, at the end of the month, based on how many failures you have, you go back through and you add those to the training set and you retrain the camera. So now it becomes significantly more robust. Everyone's time takes different. It could be a week, it could be 2 weeks, it could be a month. But once you have acquired those and you've added that to the training set, it just becomes much more robust. And now you're eliminating the subjectivity of it.
Yeah, in addition to that, there's a couple other questions. In a few of the applications Neff has been involved with VIDI, or again, the deep learning, the artificial intelligence product, it's really transformed the way the company approaches things. This particular company makes medical devices, and we appreciate the question from Mr. Dier from Nigeria joining today, a medical student asking some medical questions. But we were working with a medical manufacturer on some thermoform products that were very, very small, as used on actually part of the COVID vials, and some sealing. And VIDI was able to detect some defects in those sheets. And as such, I think they've identified 22 more places to deploy it, just because it's that much of an innovative solution. So in any case, this is not meant to be a be-all, end-all presentation. If you have specific interests, engage Nate or Chris or Ben or I or Molly, and we can talk with you about your applications. There is a specific question on the purpose best applications for the 3D camera. So Nate, maybe if you can clarify that a bit for one of the questions we have.
Yeah, so when you would use 3D would be specifically if you need any type of information from the Z-axis, whether it's above or below. That's pretty much the quickest to it. Standard vision cannot tell you any change in Z if you're looking at it from the top. The only way you could ever tell if there's a height difference is if you're looking at it from the side. So if you don't have that, and maybe you need to do gap, width, height, volume, area, all of these sorts of applications, this is where you would use 3D. Also, something I wanted to mention as well, since we didn't have a ton of time and we wanted to go over all of this to kind of just introduce you to it. I did leave out my information earlier. If somebody wants a virtual demonstration on any of this, whether it's the deep learning where I actually go into the software, I show you how to program ViDi Red Unsupervised Mode. That's the one where you train it on good products and it finds the bad. Or the 3D L4000 camera. I'm able to do that. Next week is pretty much wide open. So if anybody wants a more in-depth look, or maybe they would like to discuss this more and not with 30 other people, feel free to reach out to myself, Chris, or Ben Mintz, or even John Bridgen.
Yeah, if there's any other questions, it looks like there may be. We'd appreciate answering them. So this is back to ViDi, which is also the D900. Can the D900 reliably detect 1/2 inch features from 7 feet away for bin picking purposes?
I would probably short answer is no. So unless if it's random bin picking, probably not. Because obviously we can't do 3D, or it's a 2D camera. So there is no depth with that, so that would make it pretty much very difficult. Also, our limitation currently with our D900 series is 5 megapixel and a 1/2 inch tolerance over 7 feet. Probably, I can't do the calculation off the top of my head, but it probably wouldn't meet that.
All right. Well, I think we've answered them all. If not, feel free to type them in here as we wrap up. And I think Molly had a survey we would appreciate everyone participating in so we can improve these as we move forward.
Yes, thank you, John. I just go ahead and launch that survey. It's just a few questions. Let us know how we did today and how we might be of service to you in the future. As John said, we do still have some time. If you have a question, feel free to use that Q&A box. As has been mentioned, feel free to reach out to any of the presenters or myself, and I can put you in touch with them. We appreciate your time today. I appreciate, Nate, you putting this together and giving this information to us. Special thanks to NTMA again, and Neff Automation, and Ben and John for partnering on this series, and all of you for joining. And as we just wrap up, I see quite a few folks have taken the survey. Thank you for that. I'll invite you to check out nwirc.org to see what other webinars and trainings we have coming up. And we'll give it another minute to see if anybody has any questions. But John or Nate, if either of you have any final comments you'd like to make, I will give the floor back to you.
Yeah, thank you very much for everybody coming. I know time is always of the essence. I'll stick around for a couple of minutes here after in case anybody has more questions. Also, my phone number is 440-429-8299. Once again, 440-429-8299. If anybody wants to give me a call, I'll be glad to talk to you about any of your applications.
Yeah, I think the last closing points I would have is that both of these tools are outstanding fits for quality. As global manufacturing pressures increase and American manufacturers try to be competitive, one big advantage traditionally held by American manufacturing is the quality. If that can be ensured by the tools of doing these inspections, that goes a long way, and it's been impressive. So if you're not on the quality side of this and you're part of a manufacturing organization, I would encourage you to maybe encourage your quality people to reach out to us, because this tool, if known to them, might be something they can also take advantage of. So we appreciate everyone's time, and hopefully get a chance to work with you to show you this technology in your applications moving forward. So thanks, and have a great day.
Thanks, everyone. Have a great day.
Take care.